The machinery is two-stage pyrolysis unit. What we are doing is pyrolysing a mixture of pistachio shell and nut and urban green waste compost, and we're turning into biochar and bioenergy. The first chamber is the pre-dryer. The second chamber is where basically the main business of the whole operation happened. In that particular chamber, we're actually heating the biomass to a temperature of between 500 and 550 degrees centigrade. Going further to my right is basically the char exit end where the final product comes out. And I guess the basis of our system is a subtle air management of our syngas flow, both from the pre-dryer unit and the main reactor chamber. We have no valves, seals on the unit. What you see behind us is a system that is basically running on equilibrium, as I like to call it. The air management is just managing the syngas, saying, okay, we want the gas to go to the furnace, or we want the gas to go to the condensers, which are on the other side of the unit. We will either scrub the syngases through the condenser system, extract the tars, the condensable compounds, which have their own intrinsic value. The whole process really produces three products. The biochar, carbon material, which we use for our amending and rebuilding our soils. A liquid fraction, some people call it a wood vinegar, particularly in Japan and China. A condensate, liquid smoke, call it what you may. Basically a soup of pyroligneous acids and a lot of other good things which are basically food for the microbes in the soil and food for plants. That's the basis of that particular product stream. And the other thing, the major thing that sustains the whole process, is that we use the syngas, the smoke gases, if you like, to fire and maintain the whole process. Once we've done more testing on this feedstock and tuned the machine to the material, it should comfortably handle 300 to 350 kilograms of feedstock per hour, producing 100, 110 kilograms or maybe 120 kilograms of biochar per hour. And per hour we're also producing around about 120 to 140 litres of condensate. Back home we have had wonderful success with mixing the biochar with the condensate from the particular material that we use, which is poultry litter, and we've had wonderful results, field trials and feedback from farmers and consumers that, hey, this biochar, it's not only a wonderful soil amendment and soil builder, but with the condensate added back to it, it's also a wonderful fertiliser in its own right. We are, I guess at this stage, the knowledge that we have in pyrolysis is immense, but we have so much more to learn. And each time we play with these machines, we play with different feedstocks, hey, wow, this is wonderful. We're getting fantastic results and different combinations. It's basically a never-ending story. It's a wonderful story, and we're only really at the beginning of the pathway to discovering what we can do with biochar, the amendments, the gas. We're not at this stage with this particular effort trying to export gas, but if, for instance, we were to use just straight pistachio nut and shell material on its own, hey, that's rocket fuel. We don't get anywhere near the char yield, but we're exporting 60 to 70% of the gas we produce. We just can't consume it in the process. We need to export it. We've built an afterburner which is on the other side of the machine as well. We had a 10-foot blue flame in the afterburner. I can't tell you off the top of my head how many kilowatts of energy that is per hour, but the potential to get the bioenergy and a clean gas and a renewable gas is immense. Yeah, it's a wonderful story. we're at the beginning of it, and let's all just keep rocking and rolling and develop it. This is what it's all about: making biochar, making carbon material that's going to stay in the soil for hundreds, if not thousands of years. It's one way of really addressing the ills that we've put on our farming land and our farming practices, our agricultural practices. This is not just creating a sustainable farming system, agricultural system. It's about regenerating soils, making poor soils good. This is terra preta to India. This is turning those Amazon basin depleted, terrible clay soils into humic, vibrant, productive soils for centuries, thousands of years in the future, for our kids, for their children, for everyone's children. Biochar. That's what it's all about.